We're going to determine the derivative of
Yes.
2.1 and 2.2 were limits as h approaches 0 and f(x) plus h minus f(x) all of h. I just didn't know you were doing it.
Do we have homework for that?
What? Leave it on. 1.5 is the infinite one, which we're not doing until we do graphs. 1.6 is this weird delta thing that's not the truth though.
Sounds good. Do we have homework for 1.2.1?
No, because I made you do them in class.
Okay.
All right. So if f of x equals, we'll go A. So remember, when it's just a basic polynomial, so in this case it'd be a constant function at root 3, right? What happens when we have constants? We've talked about this already. What happens to the constant when you take the derivative of it? It goes away. So it's replaced with a 0. Now remember the reason why is you have root 3. If you want to give it a variable, you can. You can give it x to the what? 0. Because x to the 0 is just 1, right? It doesn't change anything. And when we go to do the derivative of it, we'll drop the 0 in front, so we'll get 0 square root 3 x to the negative, which doesn't matter. 0 times anything is just 0, right? So every constant, when you take the derivative of it, turns to 0. So B, what if I give you f of x, if f of x equals pi? Be 0, because pi is just a number, right? 3.14159, dot, 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 dot. Okay, C, what if I give you y equals 5x to the 4? The derivative of this can be written two ways. You can go y prime, that means the first derivative, or they could go dy over dx, also means the first derivative. Y with respect to x, because x being the variable. If this was 5t to the 4, then it'd be dy over dt. Okay? So, what do we do when we get this? We've talked about it. What happens? The 4 drops in front. We get 5x to the, what now? 3. And it decreases by 1. So we get y prime equals 20x cubed. Or dy over dx equals 20x cubed. Okay. What if we do, they can sometimes ask it this way too. D over dx x to the 10th. See, there's no equal sign in there. D over dx just means the derivative of x to the 10. That's all it means. So the derivative of x to the 10 would be 10 x to the 9. Those are all your different notation. Questions for these ones are problem 1 and AP practice problem 1. What if I give you this? U of x equals pi to the 4x cubed. What would you do?
Drop the thing.
Right, so we're at u prime of x, and we drop the 3 in front of the pi to the 4. And the reason why people think that normally, like you haven't done product rule yet, product rule is when you have two functions multiplied together. So when product rule comes, people will try and do this as a product rule, which you could get away with. But pi to the 4 is just a number, right? It's like 10, 4, 7. It's the exact same thing. It's just like a number, so you drop it in front. Yeah.
So if that's a constant, wouldn't this equal 0?
There's an x cubed behind it. That's not a constant. A constant has no variable.
But the pi to the 4 is, and they're being multiplied.
Yep, so if I had like 4x cubed, would I just drop the 4 off?
No.
No, it would join it and be 12x squared, right?
Yeah.
Same thing here. Instead of a 4, we just have a pi to the 4. So the 3 joins it and multiplies by it, which is just 3 pi to the 4. And then your x drops to a 2. What about 3x squared plus f of x equals 3x squared plus 8? F prime of x would equal 2 drops in front, joins the 3, so I get a 6. X to the 1, do I have to write the 1? No. What happens to the 8?
0.
Yeah, so I could go plus 0, right? Or just write nothing. This one is problem 31. G. Negative 1/2 u squared. U of x. You try that one. So I get u prime. It had been doing so well, hey? And then, not more. Whatever. It wants it to be up there, we'll leave it up there. Okay. We'll go to negative 1/2 u to the 1, which results in what?
Negative u.
Negative u. Okay, the next example involves differentiating a polynomial function. So A is find the derivative of, I hate the word find, but we use it all the time, so I'll use it. It should be determine. Find, here it is. Found it. Find the derivative of f of x equals 2x to the 4. Minus 6x squared plus 2x minus 3. So you find the derivative of that. So f prime of x equals what?
8x cubed minus 12x plus 2.
We're just taking the exponent, dropping it in front, and reducing it by 1. Okay, what about b? b says, what is f prime of 2? So where's the 2 going to go?
For every x.
For every x in the f prime function. Yeah. We get 42. What did we find?
Slope at 2.
What kind of slope? The tangent slope at 2. 2 and what? What would be the point? What would be the y? How could I find the y? Plug it into the original, get your y, right? So that would be the tangent slope at 2 and whatever that y would be. Okay, C. Find the slope of the tangent line to the graph of f. At the point 1, negative 5.
Squeezing down from the last equation.
Yep, it's all from the same thing. So what are we doing here? We want the slope.
Plugging
Plugging
in
in
for the x values.
1 for the x value of the first derivative, right? Right. Everyone get negative 2? So you can't show f prime of 1 equals negative 2. You have to say the slope of the tangent. What do you think I'm going to ask him to do in D and E?
The same thing but for different functions.
Nope. That would be easier. What else did we do yesterday?
Slope of the normal line.
Slope of the normal line. I also might make you just find the equation of the tangent and the equation of the. So D is to determine the equation of the tangent. I want both equations too. I want the slope y intercept and the point slope form. And then E is going to be all right, so the equation of the tangent for this one, we can do y minus y1, which is minus a minus 5, so plus 5, equals negative 2 x minus 1. And that would be perfect if it's point slope form, right? AP test, like 90% of the time is actually point slope form, so it's nice. And people are like, why do we use this? I'm like, because it's easy. Just don't fight it. Like, there's one thing that's easy. Can we just be happy with it? So when you have a point and slope, it's easier. If you want to punch this into your calculator, you could actually do it quite quickly, even in point slope form, because you can minus the 5 and type it in like a weird looking equation, right? It'll still go in for you. You don't have to make it slope by intercept form in order to type it in. It's bothersome to me because I'm so used to being able to distribute and collect like terms. But you can just put minus 5 back behind the brackets and it'll go in properly, right? But I did tell you to do slope by intercept form. So we'd have negative 2x plus 2 minus 5. So we would get, if I write too fast, this computer's not happy, so it's really ugly. 2x minus 3. Did everyone get that? This is point slope form, slope by intercept form. What's the difference between the tangent and the normal?
The normal is the negative reciprocal.
Yeah. So if we go m normal, instead of it being negative 2, it's going to be 1/2. So we're going to get y plus 5 equals 1/2 x minus 1. That's point slope form. Into slope y intercept form, we would get y equals 1/2 x minus 1/2 minus 5, which gives me y equals negative 1/2 x minus, or sorry, positive 1/2 x, sorry, minus 11 over 2. All right, these ones correlate with problem 33. And AP practice problems. Two, 5, 6, 9, 10. Okay. Leave very little left, and then you have time to work on stuff. So example. This wants us to find the points on the graph. F of x equals 4x cubed minus 12x squared plus 2. Where F has a horizontal tangent line. Key here, horizontal, tangent, line. Tangent line is what?
Sorry, no, horizontal tangent.
Horizontal tangent line is when it's 0. Tangent line means what? First derivative tangent line, first derivative tangent line. So what are we looking for? We're looking for when f prime of x equals what? 0.
Wait, would this not be the vertex? If the tangent line is horizontal, why are you setting it to 0?
Give me a 5, because that you're supposed to discover in chapter 4, but that's okay.
Wait, why?
Can you just give me a 5? It's fine, you've done this before. You've had a little lapse in time of ruining movies for me and stuff, but yeah. So this happens when you have vertexes or when you have maxes or mins, because the only place you can get a horizontal line is when it can be horizontal and not cross with the rest of the graph, which happens when you have a curve, like point of inflection, or a max or a min, which we learn in 2 chapters from now, but David just destroyed that for me. That's when we get to like, I was like, da da da, and this is how we find our maxes and our mins without our calculator. But no, David just annihilated that one. Thanks, David. And your brain, big brain. I never would have learned that. I had to learn it when someone taught it to me. That's when I learned it. But it makes sense. The only place you can have a tangent line is on a maximum, because if you have it anywhere else, a horizontal tangent, it's going to curve, right, to go with the graph. So remember how I told you if they ever ask you for a max or a min in 30-1, you have to be able to use your calculator, but when we get to grade 12 calculus, they can take away the calculator from you because you can find it? Yeah, it's when the horizontal lines equal 0. So when we get there in 2 chapters, they'll just be annihilating that. Oh, so smart. Okay, cool. So f prime of x is what? I like smart people. I like not smart people because those are me. But I also like smart people like you. So what do we get when we do tangent lines? Or what do we do when we do first derivative? What do we get?
Log x squared.
Yeah.
Minus 1/4.
And what do we have to do? Yeah, set this equal to.
Oh, sorry, 0.
Yeah, and then factor GCF. So what can I take out?
12x.
12x. I just can't even anymore. And then we get x minus 2. And then just like grade 11, we set it equal to 0. And x equals 0. And this one, x equals 2. Now, I'm not going to box those because it asked for what? Find the points on the graph. So now this is where people get stuck. Do I plug this back into the first derivative to get points on the original graph? Or do I plug it back into the original to get points on the original graph? If you say, what place do I plug it in to get points on the original graph, it kind of gives away that's the original. So if you say it that way in your head, it's actually helpful. If we plug it back into actually the first derivative graph, or first derivative, we'll just get 0, because that's, we're just going back to where we were, right? So we have to plug them back into the original. So now we're going to find f. Okay, f of 0 and f of 2. So we found our coordinate. First one's at 0, 2. And we plug 2 in. You negative 14? Yeah, times 14.
Put in 3.
Yeah, I knows how to get another thing, puts in a 3 instead of a 2. That'll happen. To get you. So this one also wants us to see where is f prime of x greater than 0? This will be a domain. And then where is f prime of x less than 0? So we know we have the places where it equals 0. It equals 0 at 0 and, right, yeah, 2. So it wants to know where f prime of x is positive and where f prime of x is negative, technically, right? So how can we figure that out? Plug in a value, yeah, less than 0. Plug in a value between 0 and 2 and plug in a value greater than 2. We agree? Because then it'll tell you if it's positive or negative in those spots. Because it wants to know where it's positive and where it's negative. So we're going to have between negative infinity and 0, between 0 and 2, and between 2 and infinity. And the reason why we say these is this is where f of prime of x actually just equals 0. It's called critical numbers, and we get 2 chapters from now. What was f prime of x? 12x squared minus 24x. Now you can pick anything less than 0. I'm going to pick negative 1. If I have a choice of 1s, that is what I will pick every time. So negative 1 squared is positive 1 times 12 is 12 plus 24, so it's 36, which is positive or negative? Positive, right? Positive 36. So it means f prime of x is positive over there, yeah.
Isn't that 2, doesn't f prime of x equal negative 14? Or is it
F of x, your original. That's a coordinate on your original. Remember we plugged in 0. Yeah, we plugged in f prime 0 for f prime of x for these ones. Then we try 1, because it falls between 0 and 2. And I'm going to get negative 12. So it's negative there. Then I can choose 3. So I cannot do it in my head. Oh, there's 6 again. Yeah, it's cubic and it's equidistant. This is quadratic and equidistant, so it should be the same number. So, we always take intervals when they ask us where f prime of x is greater than 0 and f prime of x is less than 0. Actually, where f prime of x is greater than 0, your graph is increasing. And where f prime of x is less than 0, your graph is decreasing. I'll show you in a second. That's in 2 chapters from now as well, but you can see it ahead of time. So, f prime of x is greater than 0 when it's positive. So, from negative infinity to 0, round bracket. Now, we don't use square brackets because at 0, it's actually equal to 0, right? Or 2 to infinity. And f double prime of x is less than 0 from 2 to 2.
Why is it F double prime?
I don't know. I really wanted to get to, that's 1. I don't know what you're talking about. We're not reeling back the tape. Second derivative gives you concavity. So we're going to type the original into our calculator. So the original was it was 4x cubed minus 12x squared. Oopsies. That's 2. So let's check out our maximum. Second trace max. What do we do when we get e to the negative 7? What does that just mean? 0. So we have a maximum at 0, 2. We had a maximum at 0, 2. We know we have maxes or mins at those points, right? That's where a horizontal tangent can happen. Because I can draw a horizontal line there, like this. Like that. Here's my minimum. I can draw a horizontal line there. I'm suspecting it's going to be at 2 and negative 14, right? Then we said it was positive. It was above 0, from negative infinity to 0, and 2 to infinity, correct? What's this graph doing? From negative infinity to 0, and 2 to infinity. What's it doing? Increasing. And what's it doing between 0 and 2? Decreasing is where the first derivative is negative. So we do a whole chapter on that. Yeah.
Sorry, why is it round brackets and not square?
Because that's where it's equal to 0, not greater than or less than. So if you look at this, I asked you where it's greater than 0 or less than 0. So I can't include these values because that's where it equals 0.
Okay.
You're welcome. Okay, and that is problem 37. An AP practice problem. I put the answers to these on last one too, because I only had chapter 1. 3. You get the rest of the time to do those.